right, hello everybody. So thank you for coming out to the June meeting of the Policy Simulation Library hosted at AEI. So today we have Max Ghenis to present on some of his work with tax calculator and microdf and Python application. But before that, we do have a couple of updates from the community. So first up, we have Derrick Choe presenting his opioid cost model.
Hi everyone. So as Max mentioned, I'm Derrick Choe, and I'll be presenting basically my opioid cost model. What we'll be presenting is a new fact map that shows cross-section variation between the cost of the opioid drugs. This is based off of my scholar's work, Alex fellow here at AEI, and in March of 2018, created a paper on geographic variation of opioid crisis. This was co-authored with Scott Ghenis, who has collaborated with AEI last week. When that paper came out, Gani created a product that most people hadn't seen, which was a way of actually estimating one's local costs behind the opioid crisis. So they got a lot of attention from government officials, from other researchers, and from the media. And they didn't have a very good way of sharing the results. They would just send them notification files between Excel files the data. So they decided to create an interactive map, which allows you to see different types of costs at the state and county. So I can show some tonight. Was anyone here from Texas? Oh, phenomenal. And so we're going to see, if you want to come over here and see how bad things are in your local county, we can do that. So we can see that in net, Texas is doing all right in terms of their estimated opioid costs at under short of $700 per capita. It should be noted that all of these estimates are per capita. And where in
Fort Bend County.
Do you want to go
It's like west of Houston. A little over?
west?
Yeah. Down.
Oh, Fort Bend. Oh, there it is. All right. So you can see here that Fort Bend has estimated costs of just over $500 per capita. Can everyone? I guess it's a little hard to really quick. Another interesting aspect of Scott and Alex's project was that they broke down costs into fatal and non-fatal costs. You can see here that we changed color to the red fatal color, and see that again, Fort Bend does not experience very fatal costs. We can try out healthcare costs next. Let's see over here. Okay, so. And it looks like you guys are doing. You can always zoom out and view other states' costs, but I think that you all understand how this works. I can take questions, but I don't think that there's too much else to say. This is part of an ongoing effort to open source all of the materials from this opioid cost model. This is just the prettiest thing to show. So you'll be getting updates from us.
All right, thank you, Derrick. So the next update is actually from me. So a while back when we had our tax calculator policy simulation under we talked about this online web application you can use to run tax calculator yourself without having to do any programming. So since then, we have archived that application and sort of stopped working on updating it, and instead moved tax calculator over to a new website called compmodels.org, which is just a platform for hosting computational models such as tax calculator. And this has been a new project called TaxBrain, which I've been working on along with Hank and a few others. And it's essentially the same interface as we saw with the previous website. You have all of your policy parameters on the right-hand side. You can change your start year for your analysis. You can pick your data source. And it runs pretty much the exact same as tax calculator or TaxBrain used to. But now we do include some behavioral assumptions for things like the elasticity of taxable income. So you get the same sort of interface and feel for it. It's just now on a new website, and the outputs are also slightly different now. Not much, but we now have an additional graph you can look at and download if you would like. We have the same type of tables, one that's showing the aggregate total liabilities by reform, change, and the things in zero form and current law. Or we have these more detailed tables that show the distribution of the effects of your reform. So they'll break it down by API group, where you can look at who's filing for a standard deduction, how much they're filing for and receiving that deduction, how much taxable income do they have, and you can do that for every year of your analysis. So we go out right now to 2029, and you're getting the same results. Or if you don't want to do API groups, you can also break it down by API deciles. So again, it's more or less the same experience that you were getting previously, but it's now on a new platform for everything, essentially a sense archive the last platform. So with that, that is the last of our updates. We can now get to our main event. So today we have next Ghenis, the founder of the UBI Center, which conducts open source research into universal basic income. He's a contributor to Tax Calculator and a consultant on these embedded council data projects, both of which are incubated here at AI in the Open Source Policy Center. He previously worked at Google as a data scientist, most recently working on YouTube's emerging markets products. Without further ado, Max, it's all yours.
Thanks, Anderson, and thank you all for being here. It's really a pleasure to be around AEI and especially the Open Source Policy Center, because I've benefited greatly from all the work that you guys do, and I appreciate the investment. So as Anderson mentioned, I'm the founder of UBI Center, and that's looking at open source research into universal basic income policies. So I'll be talking a little bit about that. I'll be formally launching later today, so you guys get like a couple hours sneak peek. And also the microdf Python package, which leverages the TaxCalc Python package for some additional visualizations and other kinds of functionality. So a little bit of background, I think Anderson covered this, but I just wanted to reiterate because I started getting more interested in economic policy about 5 or 6 years ago, but I didn't feel like I had a great way of getting my hands into the data. So I discovered TaxCalc around the TCGA time in 2017, and sort of realized there's stuff that I can do, even though I'm not formally in the economic policy world. I wasn't in academia, I was just sort of in the industry, but totally different industry. So I started using TaxCalc to analyze UBI and some other policies. And I got so into this that I left Google last year to focus on this, and now I'm sort of working with OSBC on some other things. So I think there's opportunity. There's so many reasons I think to value open source research in the economic policy space. But I think one is that I think I'm not alone in having this sort of latent interest, and I think we can attract a lot more talent to the industry by doing more open source work. So with that, there's also this UBI Center thing, which I'm launching later today. So I'll go through that. And I want to talk about what open source means to the UBI Center. So this is all kind of small, but everything's on GitHub, same as OSPC materials and all the policy simulation library guidelines. So right now there's a few folders with everything from icons that go on the website to the notebooks that power the analyses that also go on the website. So everything's sort of Jupyter, Python based. All the analysis is in these Jupyter notebooks, so there's some code that you can just look through, and a lot of these charts are basically copy pasted into the blog posts, or they produce CSV files that then power the website interactive tools. All the dependencies are all, of course, open source projects in their own right. So TaxCalc is a really important one, microdf, and then all these sort of standard Python data analysis libraries, pandas, NumPy, matplotlib, all that. And really trying to dig into issues, using issues for as many things as possible. So everything from analyzing the wealth inequality, that's sort of a feature request for an analysis, or changing some parameter that goes into the website and the interactive tools there, and even sort of the tax deductible status, so sort of really getting meta on these GitHub issues. So the first analysis that I've done is the Andrew Yang Freedom Dividend. Andrew Yang is a presidential candidate. He'll be in the debates, I think, Wednesday or Thursday. And the centerpiece of his platform is this Freedom Dividend, which is basically UBI. And since we'll be going through that, I want to explain that briefly. So this is $1,000 per month for every adult citizen. And it does interact with the benefits that people currently get. So if you get benefits from TANF, SSI, SNAP, WIC, and unemployment insurance, so it doesn't include Social Security, Medicare, or housing, then you have to basically rescind those in order to get the UBI, or you have the option of keeping your current benefits and declining the UBI instead. There are a few other funding pieces to the package, so 10% VAT, financial transaction tax, and there's actually a two-part carbon tax. It's $40 per ton carbon tax, but half of it goes to other projects, not the Freedom Dividend, so that's sort of modeled separately. It also lifts the payroll tax cap on Social Security contributions, and it treats capital gains as ordinary income. So I'll be going through some of the analysis here. This is all static analysis, so no dynamic labor response or macroeconomic factors. And this is at ubicenter.org. So there's a few things here, but I'm just going to jump straight to the UBI Plan Explorer. So this is basically a calculator for different UBI plans. And it takes just a minute to load up. So by default, it shows the original Freedom Dividend. This is what Andrew Yang himself has proposed. And it shows a variety of statistics, such as poverty and inequality, and also the median income. Deficit rises pretty enormously, so it rises by $1.4 trillion per year in my analysis. So you can get a lot of poverty reduction if you throw a bunch of money like that. And then also there's an interactive chart with the disposable income change as a percentage of existing disposable income. So that's income after taxes and transfers. So this over doubles the disposable income for the bottom decile, and it has a negative 3.5% change on the people in the top decile. And here I think is the little bit more interesting piece. So there's a household calculator. You can enter characteristics of your own household, which are really tax units, but save that for footnotes. And it will tell you the average change. So by default, it shows you the average net change for all households, which in this case is a bit over 700 more a month. And the UBI, because households have different number of adults in them, the average is about 1,400, minus some in taxes, and then people also see their benefits reduced on average, or they reject the UBI. So that's sort of this last element. It also has a distributional chart, so you can see what share of people are in households that experience a change of a certain range. So 80% of people are in households that would see an after-tax income change of 5% or more. So let's actually filter this down. Let's look at single adult, maybe one child, and let's say they're sort of middle income, and let's say they're actually getting benefits. So in this case, they're still going to have a net change, but they are losing a fair amount in benefits that sort of draw back from the UBI. And it's still about 90% that gain. 85% have a disposable income change of 5% or more. But there are, these are mostly at this level people who have a certain level of benefits that exceeds the amount that they would get in UBI. So they're basically declining the UBI, but they're still paying VAT, carbon tax, those kinds of things. So that'll put people into this bucket. Also shows the number of people. And then the last thing I'll show is there is an adaptation of this, which is a revenue neutral Freedom Dividend. So I basically pulled down the UBI amount such that in this static analysis, the total deficit is unchanged. And in this case, the math works out to be $478 instead of $1,000 per adult citizen. Still pretty substantial poverty and inequality features, but now a lot more reduction to disposable income among the top, so almost 9%. So there's tens of thousands of dollars for most people in the upper decile. And it saves us, so actually on the revenue neutral one, this now single parent with 25 to 50K with benefits is coming out slightly behind. So the 478 doesn't quite make up for the new taxes and the loss of benefits. But there's a lot of heterogeneity in these types of households, so it's kind of half and half between those who come out ahead and those who come out behind. And then this all links as well to, so this will link to an actual blog post once I launch later today. But so this is a dynamic thing. It'll point to the right report depending on which plan you're in, and it will show you basically a blog post with the breakdown of the costs. And then I want to show a couple of the charts that microdf powers as well. So this is kind of an interesting one. I think usually you see charts like what we saw before, which are something like this, average change in disposable income by income decile. So this is actually the kind of chart I think that TaxCalc shows by default in TaxBrain as well. And sort of as a percent we just saw. So this is negative 9% in the upper decile. Another way of looking at it is instead of breaking down people by what group they're in initially, just characterizing the income distribution. So you can characterize the sort of baseline income distribution and then the end income distribution with sort of ignoring who are making transitions. And that's what we see here. So this is basically the revenue neutral version. It sort of compresses the disposable income distribution at both the bottom end, so people at the bottom come up, the median income comes up as well, and then the 90th percentile falls. So, and then this is another chart, kind of hard to see, but it's basically the distributional impact, not just overall, which this is also what we saw before, but also by income group. So you can see that basically everyone, literally everyone earning 500K or more in the revenue neutral plan would come up behind. And even people with zero or very low income have about a fifth probability of coming out behind as well. So that's all for OpenUBI. Let's see. Sorry, UBI Center. The initial name was OpenUBI, and then it was a cryptocurrency kind of thing, so I have to change it. But it's still in my mind. Okay, so the next step for the UBI Center, more analysis. So I want to do a lot more UBI plans. I mean, Charles Murray has put out one. There's a few other thinkers as well who have put out UBI plans that haven't had this sort of distributional impact analyzed from what I've seen. Also design UBI plans. So I was doing actually an exercise where you would tweak the amount for each age group such that you minimize losers, so minimize the disruption. So I think that's the kind of thing where it could be an intersection of almost machine learning kind of technology and public policy design. So that's what this optimizing parameters would be, and then expanding beyond the US as well. But really also want to do more open source. So everything I shared was on Google Sites, and Google Data Studio is the dashboarding technology. I'm loyal to my former employer, what can I say, but it's not open source. So I want to move that all toward GitHub, have it be on GitHub pages. Same thing, the blog posts are going to be on Medium in the short term. Those will be in Jekyll, which is an open source way to use GitHub pages. Really the entire website and supporting the open source community, getting more of the packages that power this into PSL. So yeah, want to sort of partner with all of you on doing that. With that, so that's the end of the UBI Center section. There's also a Python package which I've used pretty extensively for these types of analyses called microdf. And you can see it on GitHub at bit.ly/microdf. And the name really comes from this idea that we have a lot of microdata that's sort of the core of what's used for a tax calculator, and a lot of more advanced public policy analysis. And data frames are this really great way to do analysis when in R and Python now. So I think there's a lot of tools in R for dealing with microdata. Python is a little bit behind in that area. And also, tax calculator as an interface is not data frame first. It's sort of object-oriented programming. So a lot of people who use Python in this more data frame kind of way tend to have this other, subsequent steps that I think can be boiled down a little bit. So yeah, as I said, I think TaxCalc is this really great tax calculation engine. It powers has many different endpoints. You've got the command line, TaxBrain, as Anderson showed, and Python. I think Python's kind of a minority of that. I mean, certainly compared to TaxBrain, but also compared to command line. So I think there's opportunity as more people are getting into Python, especially in universities and things like that, to boil down some of these steps so you're not doing CSV exports from the command line and putting it into R or Stata or something like that. So you can do this today. There's basically once you create a calculator object in TaxCalc, you can use the .dataframe method to create a data frame out of that, and you basically pass along which attributes you want from the calculator. So you can get HEI or number of people in the household, those kind of things. And then you basically post-process to usually add weighted metrics, the weighted after-tax income or expanded income. Those are kind of common post-processing steps. So some of that I want to boil down in this calcdf function. So this is probably the function that I use the most in microdf. And this basically takes a few parameters, but I would make note of the equals none, because that means that those things are not needed in when you create this function. So you don't have to pass records, but if you don't, it'll just give you stuff based on the CPS data in TaxCalc. You don't have to pass a policy, you don't have to pass a reform. So if you just sort of leave all those blank, it'll give you a baseline, which is usually, you have one of your baseline data and your reform data. So you can just leave a bunch of stuff blank if you want your baseline. But if you want, you can pass the policy object or the reform. So these are two different ways to specify what kind of tax or transfer changes you want. And then these, I think, are one of the more novel contributions, which is that you have this metric variables feature. So you can pass to that a list of different variables that you want to calculate the weighted version of. So I'll show what that means in a minute. So here we have a demo, and this is a policy purely for illustrative purposes, which would add a 70% top rate and treat capital gains as ordinary income and distribute the proceeds as a UBI for seniors, people above 65. So these are some things that be a little bit more involved to do outside of TaxCalc. So here is, let's see, I'll actually zoom in a bit. So we start just with some imports. We're grabbing the standard imports for data analysis plus TaxCalc and microdf, and some plotting libraries as well. And forgive this stuff, this is just to make the charts look pretty for you all. You can basically ignore that. So here's the first step. We're generating data using this calcdf function I just talked about. So this has no parameters except the group variables, which just means you don't want to aggregate those variables. It's basically everything except the metric variables that you want in your output. And then metric variables. So this is going to calculate, it'll give you the raw after-tax income, as well as a weighted version, which is specified as after-tax income underscore M. So that's going to be in millions instead of just the raw amount. So that's basically how much total after-tax income in millions does that microdata record represent. And then I'm sorry for these variables. I was told to blame the IRS for these really unintuitive variable names, but xtote is the number of people in the household or the tax unit, and this is marital status, Mars. So we're going to do that. It's basically now in the background calculating it's sort of advancing the calculator to the year 2019 and applying a baseline, basically no reform, and returning the results that we want. once that's done, we'll take a look at what columns are in this, and I think this will give more of a clue into what this function is doing. If it completes. There we go. Okay. So there's a bunch of features that I include by default. You can sort of turn those off if you want. So all these benefit variables. After-tax income, so that's something we specified. Expanded income, the number of people. S006 is the weight variable in this data set. And then we also have S06M, so this is just the weight in millions. And this is kind of nice because you can just multiply this by any other feature to get some other variable in millions. For example, we have after-tax income in millions, and we have the number of people also in millions here. So that's the baseline data set. We also have capital gains, this sort of new reform that we're going to do, where we're going to set all the capital gains as ordinary income and also set the top rate to 70%. So that's what's specified here. And now we can create this reform. And this is basically the same as before. We're not going to grab as many group variables, but we're passing in this reform. So same idea, it's going to run this reform and advance the data to the year 2019. We're also going to do this group N65 equals true. This basically creates a variable called N65, which is the number of people 65 or older, which is just not included in the base data set. So there's a little bit of arithmetic going on there. And we can see we have N65 here. Again, after-tax income in millions, and the number of people in millions. So now this is where it gets a little bit interesting. You can't really do a revenue-neutral reform in tax calc itself. So we're going to calculate what that UBI would be. And the first step in that is just figuring out what the new revenue is. So we're subtracting the after-tax income in millions, right? So it's billion dollars per year is what this would provide. And now here's another function that's in the microdf package, add weighted metrics, which is going to give us, in the reform file, it's going to add a new column called N65_M. So this _M is kind of the keyword that really drives a lot of simplification of the logic. So we see there's 49 million seniors, and that'll give us a UBI of about $6,000. Okay, so this is not really microdf specific stuff, so I'm going to skip over it. Another thing in microdf is it has a Gini Index. So Gini Index by itself is pretty straightforward. There's other packages that do that. It's a little harder to include weights. So this is something that this does. It says, what's the weighted Gini Index? And this is important for microdata. So we've got a weighted Gini Index in the base file of 0.45. And in the reform file, it falls by about 0.014. One other feature in the microdf package is calculates a federal poverty line. So this will tell you, just based on this for the contiguous 48 states, what's a federal poverty line depending on the number of people in the household. So we can now add a feature which is just going to specify that, and this lets us say what the poverty impact is going to be. This isn't an official way of calculating poverty, but it sort of illustrates what you could do. So this would reduce poverty by about 0.7%. And the last thing I'll show is this plot that we actually saw in the blog post. So this is the characterizing the distribution of incomes rather than from one decile to another. So this is pretty straightforward, actually. It's a quantile change plot, and you just pass in the after-tax income for the baseline reform and the weight for baseline reform. So in this case, we're going to weight by the number of people in calculating these quantiles. So X to M is sort of this weighted feature that does that. And right there, you sort of get some idea of how the distribution changes. So it actually goes up at most of the percentiles. It probably falls a little bit more at the top that isn't shown here. Cool. So that's the remainder of the demo. There's some other features in the package, so I'd welcome you to take a look and pass along any feedback you might have. So for example, Lots of this was motivated by the Andrew Yang plan. So there's ways to do custom taxes like the value-added tax, financial transaction tax, and carbon tax. And since there's no consumption data in the data set, this basically takes established incidents of those kinds of taxes from the Tax Policy Center and the Treasury Department and basically assigns the incidents by income. So it doesn't really capture the heterogeneity of the tax, but it's a good ballpark way to do this. There's also income measures like the Tax Policy Center's expanded cash income. This is an important thing for calculating the VAT and financial transaction tax incidents, and also some other features for specifying the chart style. Some next steps, really want to get this into PSL. There's just kind of some tests that I want to add before doing that. There's some more charts, for example, the distribution chart, which was actually modeled, I should say, after Anderson did a version of John Schwabish's chart that was kind of like that. So there's also some more one-line comparisons between baseline and reform. A lot of this kind of takes a couple steps. So I think, for example, in Calc DF, you could imagine specifying both the baseline and the reform together, and from there getting distributional changes that way. Standard error support wouldn't really be in the tax calc suite, but for other surveys, I think this could be an interesting thing to have in Python. So that's it. Thank you very much for having me. I guess we'll take questions at this time. For me or just, cool. Yeah. Sure.
Thank you. That was really interesting. I was wondering if there are assumptions. You know, I know a lot of what you get is from the IRS, so it's clear data. But are there you mentioned assumptions, and then there are assumptions that you have to make, and are there assumptions that to which the results will be very sensitive?
Sorry, are you talking about like the freedom dividend? Are you talking about the Andrew Yang plan, or
yes, well,
for anything? Yeah. So I think one really important thing is that everything by default that you use that's free is from the CPS, not the IRS. I think you guys do some imputation from the PUF file to get a more rich CPS file. But still you get some results that would not match what you get with the IRS PUF file. So for example, actually, just the piece where you lift the Social Security, the payroll tax, and treat capital gains as ordinary income, that results in about 250 billion using the CPS data per year, but I think it's about 350 billion if you use the PUF. So this sort of motivates what another project I'm involved in, which is to create a synthetic version of the IRS PUF file. And once we have that, we'll be able to freely distribute it to anyone. So, because you guys have a license, but I think there's a lot of researchers who would benefit from having that data be more open. I mean, all of these things tend to underreport people at the very bottom and people at the very top of the distribution. So there's, I think, always caveats when you're reporting poverty impacts from these kinds of surveys as well.
For example, how would you know how the carbon tax would affect different? There are some.
Yeah. Well, the Tax Policy Center, I think they did a pretty rigorous analysis of this a couple years ago. So they looked at, I believe, the consumer expenditure survey, where, and they basically mapped each of the expenditure types to some mapping of how much carbon it has. But it's pretty non-trivial. I think that's something else we want to do once we have the synthetic PUF, is to have it impute other data sources. Like there's someone who's working on the survey consumer finances, which would be great for wealth kind of implications, and then also the consumer expenditure survey. Yeah.
I want to go back to your revenue neutral example of Andrew Yang's plan. There are obviously a whole set of parameter combinations that will give you revenue neutrality.
Yes.
And the question is, did you fiddle with the parameters in the way that you thought was reasonable, or do you have some kind of a search and path analysis algorithm in the program to get you there?
I sort of did the dumbest version you could do, which is just modifying the, so very naive, just what's the amount. But yeah, I think it's a really interesting problem of figuring out how you would change the whole search space. So in another analysis I did, I was using Bayesian Optimization to do that, which is a technique that's used for optimizing machine learning algorithms, because usually you have between 5 and maybe 20 different hyperparameters that go into those approaches. So you can apply the same thing for minimizing sort of whatever outcome you want, whether that's deficit or something else. Yeah. Yes?
Well, thanks for speaking with us. I think what you did is very cool, combining CS and economic policy. I was wondering what made you interested in economic policy, combining the two, and specifically why would you stay UBI?
Yeah. Well, so being in Silicon Valley, I think there was this idea of UBI for a while because of the robots are coming and things. So I think that had a little bit to do with it. But once I got into it a little bit more, I have some family members who benefit from assistance programs, and so I saw firsthand that those have challenges in terms of work requirements and just complying with a whole series of requirements that you have to do. And I also got into the research from Give Directly, which is a cash transfer NGO. They basically do direct cash transfers to very poor households in Kenya and Uganda. So Google gave them a big grant around 2012. So that was sort of publicized, and I got into the cash transfer research there. So it seemed like at a high level, to me, there was some opportunity to create a little bit of a more empowering kind of safety net with some more cash. So, I'm trying to be very neutral in the plans, but I think there's a lot of UBI plans that might not be great ideas. I'm not sure if Andrew Yang's is the ideal plan that we want, or if it would even be better than the status quo. I think it sort of depends on what values you have. But as a policy idea, it seemed increasingly like there was an opportunity to add more specificity and some more data to this sort of very broad concept that can mean a bunch of different things to a bunch of different people.
Thank you very much for the presentation. I love Python and I love open source. So my question is sort of following up to the previous questions about your calculation. I noticed that you have an outcome variable named income rights.
Income rights.
So I just wonder how you actually calculate income rights, and are there mechanisms for economic growth that are included in your calculation?
So are you sort of talking about the change in disposable income?
Yeah, income rights.
Yeah.
Some percentage of that.
So again, this is just a static analysis. So I think right now it's very simple. It's just looking at how much do you get from current benefit programs. I'm excluding Medicare and Medicaid. Well, not in the example we looked at before, but with the Yang plan. But everything else sort of counted as dollars. And I think there's been some other UBI analyses that apply the discount factor based on the utility of certain benefit programs. But aside from that, it's just looking at the total after-tax, after-transfer income. And I think it will depend, you're right, on the sorts of assumptions you make in terms of elasticity of labor supply, the income effect, the substitution effect, those kind of things. And those are not considered right now, but really important next steps.
Thank you.
Sure. Great. Well, thank you so much again.